So this week, Mr. Delport, I was feeling pretty down. So I decided that I would research something that might lift my spirits.
Makes sense, rational.
Because, you know, we always talk about climate change and going green and, you know, like, is there actually hope for the future? I thought maybe, what are the chances that we can actually reverse climate change?
Yeah.
And I must say
Helpful.
that even while researching this, my depression was not cured.
At all. A little bit.
Not even a little bit.
Well, that's great.
So, yeah.
So is that setting the tone for this episode? No hope.
There is hope. There is a bit of hope.
Okay.
All right.
And engineers offer the hope. I would hope. There's lots of
This
hope.
is an engineering channel,
Why not?
and therefore we talk about engineering things. So welcome to the High Level Podcast with my co-host, Mr. Jonathan Delport. How are you this week, Mr. Jonathan?
Being pretty lacquer,
Got
man.
a nice snazzy haircut over there.
Got a very short haircut, I won't lie to you.
How does that make you feel?
I don't know. Everyone says they can't recognize me, so now I've resorted to wearing a hat.
I think people just like being dramatic.
Fair enough. Yeah, no, but otherwise, dude, doing well. I myself thought there was hope for climate change, so I really hope that you continue to give me hope. But I mean, I'm open to this week's episode. It's your episode. How are you doing this week?
No, not too bad, man.
Is it? Started out depressed, it sort of went down, and now you're up.
Yeah. So I was depressed, and then I got more depressed. But now that I know there's cool engineering solutions,
You're here for it.
my spirits
Have
are
been
lifted.
Lacquer, man.
All right, yeah. So I think we got to put this whole climate change thing into perspective. So, like, in a nutshell, and I'm just gonna say it's not reversible. The way it is now, the human race has already done irreversible damage.
No way back.
Yeah.
It's in the rearview mirror.
Yeah. So,
Okay.
but even if we had to stop all emissions right now,
I could do that.
what would happen is we would still get a slight temperature increase.
Okay.
And then we would get a plateau. And then over time, then the emissions, thanks to the trees, the emissions would be reduced.
Okay.
So this article I found from NASA has predicted that if we don't cut emissions by 2100,
Yeah.
then
End
the
of the
temperatures could rise between 2.5 degrees and 4.5 degrees. And we've said previously in episodes that doesn't sound like a lot, but we're talking about an average, which means we're probably getting extremes.
Oh goodness, I can't handle that, man.
And the general consensus is now we need to have a two sort of tiered approach on how are we going to address now. The first one is mitigation. So that's like reducing emissions
As much as we can.
Got
you.
And the second one is adaptation. So
we got to evolve.
We've got to evolve.
Okay, got you.
You know, like how reptiles, they don't produce their own body heat. They sit in the sun, and then that's how they
So are
you
telling me that the lizard people are going to take over?
Probably. Maybe they are the ones that started this whole thing. We don't know.
But the momentum's there.
So yeah. So according to the World Meteorological Organization.
Say that 3 times.
Yeah, no, it's quite like I had to think about it. I'm not going to lie. 2025, that's this year, we experienced, on average, one of the hottest summers, despite being in an El Nino Enso cycle.
An El Nino? Now you're speaking Spanish to me. No, I don't know what the heck that is.
So
Something
just
to do with rain?
Yeah, so just to kind of, because I'm sure these words have been, I heard this a lot and I didn't know what it was.
I say it like I know what it is, but I have no idea.
So you get something called the Enso cycle, which is called the El Nino Southern Oscillation. And it's got 3 states that it can be in. It can be in an El Nino state, which is, it's generally like it's warmer ocean currents. So it's generally the hot part of it.
Okay, got you.
Of the cycle.
Yeah.
Then you get the La Nina part of the cycle.
The female one.
That is the cold part of the cycle. So basically in that one, cold air is coming down, the oceans are generally cooling. And then you get a neutral one where it could be either way.
Could go either
and
way,
the cycle, it's quite irregular, the cycle. It can switch between the two, between every 2 and 7 years. So it's like 2 and 7, that's a 5-year gap.
Yeah, literally.
So so right now we are apparently in an La Nina one, which is the cold one. But despite that, we experienced one of the warmest Januaries.
Still had the hottest January.
And there's a nice surface temperature graphy that I've put in the notes over here that I'm sure you'll throw up right here on the screen.
Yeah, handies.
So that's the average temperature deviation.
Deviation against? Oh, so 0 would be no deviation.
Yeah, so this is since 1890, something like that.
Got you.
That the average temperatures, and in last year, that was, or January, that was the distribution.
So this is basically 0 would be no change compared to 1890.
Yeah.
And anything positive is greater, and
yeah.
anything negative is less. Okay.
Yeah, so as you can see, a lot of red.
This is especially
Some cool
in
parts.
Russia, eh? That's
Yeah.
crazy. Okay.
Yeah, so
And look at Antarctica, man, the polar bears. Where are they going to go, dude?
Yeah, so in that time, the average global temperature reached to about 1.75 degrees above. Now remember, the Paris Agreement is to limit it to 2.
Oh,
All right, but to put this number into perspective, you can't just take a 1 year reading for it to be accurate. It's taken over multiple years.
Gotcha.
So yeah, another thing we saw that the Arctic Sea ice, it's remaining at historically low levels. So there's less ice in the Arctic Sea, and yeah, so ocean temperatures are staying high, and we saw repeatedly that we breached the 1.5 average in there. So
I see why this depressed you a bit more, man.
yeah,
A
so
little bit somber.
so this brings us to the Paris Agreement.
Yes.
And we always mentioning
We say it
Paris
a lot,
Agreement,
those French
carbon
people.
emission stuff. So I'm
What
gonna
is it?
just
What is
gonna
it?
just elaborate. So
Give us
in
the
2015, the Paris Accord meeting was held, and then they said they want to limit global warming to well below 2 degrees Celsius, ideally 1.5. It seems like we've already missed that mark.
And that was by the end of the century or something.
Yeah,
right?
so, and so they basically implemented a bunch of rules. They call it the Paris Rule Book.
Okay.
Yeah, so where they were like, okay, in detail, they were like, okay, guys, these are the goals in terms of climate change and emissions that we need to reach. So they were saying that in 2030, there's a peak. That's where we can reach our peak emissions. And then we have to halve our emissions by 2050. And then and then I think by 2100, no more emissions, net
At least
zero.
carbon neutral.
I think a lot of places have pledged to net zero by 2050.
Yeah.
But yeah, so that's and in the Paris Agreement, they emphasize that engineers will be playing a key role. A key role.
Yes, 100%.
In this.
Yeah.
So I thought, okay, fine, 1 to 2 degrees Celsius, is it that bad?
It doesn't seem that bad on the face of it.
So what I did is I Googled, okay, what are the impacts of climate change on human health?
Okay.
Because things are getting warmer. And to my surprise,
Really
there
not that
were
bad?
actually quite a few ones.
Oh, is it? Okay.
And I've got some statistics. Sorry, I just got to fix this.
Yeah, no,
microphone
you seem
here.
to be attacking it there.
Do you know what the problem is? It's the microphone is in the way of my notes.
Oh, God.
So I keep having to...
Okay, got you.
Anyway, so the first obvious one is increased heat waves, floods, and storms. So these events, they cause injuries, illnesses, deaths, and particularly to children and elderly who are sensitive to this kind of thing. So about 3.6 billion people, as of when I read this article, so it's 2024, 2025, around there.
Enough, yeah.
3.6 billion people live in areas where they are highly vulnerable to climate change, where as in if a flood hits them, they're fucked.
Wrecked. Yeah. Gone.
Okay?
Yeah.
Then there's about 15 times higher death rates from extreme weather and vulnerable regions versus less vulnerable ones. So the people that are getting hit by this shit, they're experiencing it about 15 times worse than people that are in less vulnerable areas.
Yeah, no, fair. Gee,
So it's again one of those things where the less fortunate are impacted more than the fortunate.
Yeah, 100%.
And there's about a 37% of heat-related deaths, and they're attributed to human-induced climate change.
That's crazy.
So,
gee whiz, man.
Yeah, and there's also been a 70% increase in heat-related deaths among people who are over the age of 65 in the past 20 years.
Shame, dude. That's rough, eh?
Yeah, so there's also been another risk is disruption to infrastructure. So for instance, damage to infrastructure can lead to power outages, reduced access to essential goods and services, and an increased risk of injury. Because,
it makes sense.
Have you ever seen those pictures of Detroit? Where there was I think it was a cyclone or something like that, hurricane?
Yeah.
So I think the whole thing is it was a really rich coming up area. Hurricane came, wiped it out, and a lot of people got displaced and all of that
Businesses move away.
Yeah, so so when there's a big storm, it's it affects people, you know. Another thing is there's an increased spread of disease. So for instance, because it's warmer and more moist, so certain insects like mosquitoes, which carry malaria, they will now thrive in this environment. So there's a higher risk of those sort of airborne diseases. Also, there's an increased risk in waterborne diseases as well.
Okay, that's it. Because the temperature's a bit higher, they can thrive.
Yeah.
Pretty much.
So between the years of 2030 and 2050, there is an expected 250,000 deaths per year increase than currently due to heat stress, undernutrition, malaria, and diarrhea.
Had to throw diarrhea.
All of that stuff.
Yeah.
I mean, it's a serious thing.
It's a serious thing.
Pooping is funny, but diarrhea is not a funny thing.
Okay, yeah.
And about 2 billion people lack safe drinking water, and 600 million people suffer from foodborne illnesses annually.
Right. That's
This is
crazy.
all you.
And can you imagine now there's increased temperature and now you have lack of access to water? Oh, sounds terrible.
So, and the last kind of risk to human health that I'm going to talk about is air pollution. So, because of like increased temperatures and stuff, you have a higher risk of wildfires, and when these wildfires occur, then you get like smoky areas, damages people's lungs. It can also, the climate change can also alter the distribution of pollen. So people who have like severe allergies, like myself, experience allergies worse.
So there's like a higher density of pollen.
Yeah.
Yes. Yeah. Okay.
Yeah. So it's estimated that about 930 million people on this planet spend more than 10% of their income on medical expenses.
That's crazy. Almost 1 billion people. 10%.
And the direct health cost by 2030 is expected to rise by 2 to 4 billion a year.
Is this specifically to do with like heat stress?
This is specifically to do with medical
Medical
issues.
in general. Okay.
That people
change.
think, okay, you're experiencing these because of a result of climate change.
Okay. Yes, you dude. Okay, that's interesting.
Yeah. So yeah, dude. I mean, I think that's quite. A lot of these are quite scary. These numbers,
a little bit.
But
is there hope?
there is hope.
Is there hope?
There's hope. There's a lot of things we can do. Like
Okay.
as I said before, us engineers.
Yes.
We are problem solvers.
Right, and this seems like a problem.
And we are very much on the forefront of the mitigation part of the thing.
Yeah.
So some of the things we've done episodes on a lot of the things I'm going to mention.
So we'll leave a
The
card.
first one is decarbonization.
Yes.
So a lot of processes such as the steel industry, cement industry produce a lot of CO2 emissions. So what engineers are trying to do is look at these energy sectors and reduce the carbon emissions and so they'll do carbon capturing or maybe look at the process entirely
More efficient,
and not
yeah.
so like instead of using CO2 to heat things, they'll maybe use hydrogen.
Yes,
That's the kind of stuff
yeah,
we're
yeah.
talking about that engineers are doing. Another thing that we're doing is we are developing renewable energies. Everyone knows about solar, everyone knows about wind and geothermal.
Not possible if there's not engineers to put it there.
Exactly. So that's what we're doing. We're
100%.
making things greener.
Yeah.
And we also had a whole episode on carbon capture and utilization,
Yeah.
where we were enlightened at the fact that oil is not a fossil fuel.
Oil is not a fossil fuel, man. For anyone who doesn't know, that was a comment that we got on the video. But yes.
And I hope he sees this.
Yes.
Because oil is a fossil fuel. we also spoke about like smart homes, sustainable infrastructure, all of that. That's all part of it, man.
Yeah, 100%.
And then the last one, we haven't done an episode on this, and I think maybe
Coming soon.
future
Yeah, yeah.
episode, is
Yes.
a circular economy.
Yes.
So basically, think about it like this. Reduce, reuse, recycle.
The 3 R's. The 3 R's.
Yeah,
Yeah.
but on a much bigger scale. So we're talking about reusing building materials and roads to build other buildings and roads.
Okay,
and things
got
like
you.
that. So
Yeah,
so how can we set up the economy and the system in
So
such a way so that we can reduce, reuse, and recycle.
So
And
whatever waste comes from it, you can use it for something
yeah,
else.
so basically we're just talking about building sustainable infrastructures and things like that.
Makes sense.
And I know that we were talking about this in the week, Mr. Dalport, and I know that you really wanted to talk about the next section of how does
So you're gonna
climate
give it to
change
me?
impact food production and security. So take it away, Mr. Dalport. Explain to me how our food production is impacted.
So, Mr. Hunselaar, I'm going to take you in. Climate change, we're talking climate change. You've given us a bit of things to talk about here, but now we're going into food production, right? And we were discussing this a bit this week because we feel like food production heavily hit. I don't know if you agree with that. You agree with that on the face of it?
Yeah, I think
Right.
that's going to be, I think temperature, we've got air conditioners.
Fridges, freezers, we got all of that stuff.
Yeah.
But you can't, like, if it's a crop, it's a different thing. It's a different thing altogether. So let's talk a bit about it. Okay, so there's a few things where climate change is going to play a role, specifically in food production. And one of them is obviously, do you want to guess what the first one is? With the climate changing?
Irregular rainfalls.
Irregular rainfalls. No, temperature. We're going to talk about that with the temperature changing.
Sure, I really missed that, Mark.
You really did, even though it's on the notes. Okay, so let's discuss temperature. So obviously temperature changes is good and bad for crops. So we'll go into this a bit. It's a bit nuanced. So basically, a lot of crops do a little bit better when it's warmer. That's why growing seasons are often in the springs and the summers, okay? In general, as long as the temperature is around their good growing and reproductive cycles, crop yields will usually increase, obviously up to a point, you know, all the nuances that go in here. So the nice thing about climate change is that actually you get longer growing seasons because obviously it's generally warmer on average. Huh? Right? We're not accounting for those spikes and stuff where things could go wrong. So this is the thing. You get a longer growing season as long as, here's the caveat, as long as you can keep the nutrients in the soil and you can keep the crops well watered enough. So in general, farmers might actually benefit a little bit from climate change if they can control the water and the nutrient thing. Did you feel that?
But I feel like that's more difficult than
no,
easier
it's
said
a
than
little
done.
bit difficult because now you can imagine if temperatures are generally increasing, what's the thing that's generally going further away from you? Water.
Yeah.
Right? Because the water wants to evaporate. So it's a balancing act. And again, like you said, there's no going back now. We have to adapt. And this, I think, is going to be a part of it. So how do farmers change the way they think about farming? Because it's coming. It's probably already here, mostly, especially around the equator. All right. So one of the things, obviously, is going to be if it's hotter, you're going to have to use more water. Water resources are going to be under pressure.
Touch and go there.
Touch and go. Next one is to keep the nutrients up in the soil, more use of fertilizer. Okay? And like you discussed with an increase in disease, what did you call it? Disease vector?
Waterborne disease vectors, yeah.
Well, whatever, disease vectors. You also get an increase in pests because now pests have warmer environments to breed and grow and longer seasons to breed and grow. More pests means more pesticides. So again, it's going to be adaptable, but generally temperature, if farmers can manage it well, you're going to get higher yields in general. The one thing where it's going to be a bit funky is with animals. Obviously, there's quite a bit of animals in farming as well. And cows especially dairy cows, get very heat stressed very easily with changes in temperature. So farmers are going to have to manage that. And I don't think it's as easy as
spraying them down.
Spraying them down or I don't know what. You're going to have to put them in a large room with some form of climate control. I don't know exactly. It's for them farmers to figure out. But that's basically how temperature is going to affect crops. And obviously, there's some crops where you cannot have an increase in temperature. One of them, which we discussed briefly this week, is coffee.
Yeah.
And it's gonna break my heart a bit, man.
Yeah.
So coffee yields actually go down when they experience changes in temperature because coffee takes a very specific type of environment to grow. So all I'm saying is, if you guys see coffee prices going up in the years to come, it was the humans that did it.
Coffee's already expensive.
It's already expensive, but it's going to get more expensive because it's going to be more difficult to grow, right? So just a side note. Okay, the next thing to think about in climate change, obviously climate change, we're attributing a lot of it to increased CO2 content in the atmosphere because we're releasing CO2 into the atmosphere, obviously. Now, I didn't actually know this, but increased CO2, lots of plants like that. Because CO2, obviously, plants use CO2. They use the carbon
it gives them
in
their
the
mass.
CO2, right? Gives them their mass. You taught that to me.
Yeah, because did you know
Do it.
that those rock flowers,
The succulents.
they can consume about 4 tons of carbon monoxide a day.
That is fake news. Everyone knows that's an inside joke. But I love that. So yes, so plants use CO2 actually for growth. And I think I put it down in here. You'll see there 0.4 there. You can see some, they did a little study on, and now this is in a lab, so I feel like it's obviously different when you get out there. But plants generally grown in a higher content CO2 atmosphere experienced up to 21% greater above ground growth, so the leafy part of the plant, and about 28% below ground, so the roots and all of that crap. Right? So CO2 actually very good for plants. Again, to a point.
And I just thought now.
Tell me.
So, they call it greenhouse gases.
Yes.
And you grow food in a greenhouse.
Is it all making sense?
So
now?
it kind of
Did you they're double dicking there, getting it in. Okay, fair enough. So I think in general, as caveats to this, growing plants is difficult and very complex. You can't it's not like you can just increase CO2. That doesn't happen on a farm. Usually you're increasing CO2, you're increasing temperatures, you're increasing water use. There's a whole bunch of variables in this, but generally CO2 is very good for plant mass. However, if plants grow too fast or too much, often their nutrients or their minerals are not as great in content. So you get an increase in quantity, but not necessarily
nutritional value.
quantity.
Like nutritional
did I say
density.
quantity and quality. Yeah, exactly. So a lot of the plants that are high in protein, you'll see less protein content, or you'll see lower amounts of calcium, stuff like that. And this is particularly important for when you're running pastures with sheep and cows and all of that stuff. You need to eat the stuff. Now you need larger amounts of land for the cows to get the same amount of nutrients and grow.
Yeah, and I think also another thing is now that you mention it.
Yeah.
So the cows will eat more, they'll get fuller quicker because they're eating more, but they won't
Necessarily get the nutrients.
get the nutrients they need. So you'll have cows eating more, but also not growing as much.
Exactly. Or you'll have to supplement their diet with artificial nutrients, or lab-based nutrients.
Oh, we do that already, but yeah.
Yeah, but obviously you're the animal feed dude, right? So in general, fairly good. I'll just give you guys a breakdown. The general plants that like more CO2. So these are things like wheat, rice, soybeans, that type of plants. Plants that don't really care include crops like corn, sugarcane, millet, and some subtropical grasses. If that means anything to you at all. I don't know if you're a big grass man. You put a lot of grass in salads. But anyway, that's grasses for you. So in general, CO2, they like it, but you got to supplement it. There's got to be enough nutrients in the soil, and you got to have enough water available. I think that's the general thing I learned from researching this. Doesn't help to make the plant grow faster if there's not enough nutrients.
Yeah.
Okay, then final thing to discuss here is obviously there's going to be extreme weather events in this. Like you keep saying, this is an average increase, but there's those extremes within that. When you look at the table,
and that's when the
values,
damage happens.
That's where the damage happens, right? So farmers are going to have to continually make plans against natural disasters and things like droughts, things like hurricanes, flooding, like things that you can't control. I think go for it.
One thing that's like dangerous about a flood is it will wash away a lot of the nutrients that's in the soil.
Exactly.
So the farmer might lose the crop because now his crop's drowned and washed away. But also now
he has to replenish the soil.
He has to replenish the soil. And then we've spoken in a previous episode about how you get something, what's it called again, when you plant more than one type of crop?
I know what you're talking about. It's not agroforestry. That's where you plant the trees. But I know what you're talking about. Yes.
So I mean, that's a nice sustainable way of keeping nutrients in your soil.
Exactly.
Because you'll grow this specific type of plant that gives the soil a specific type of nutrients, which this other plant thrives in.
Exactly.
And now
holds the ground together.
Yeah.
There's a lot of plants that do a lot of different things to help each other.
Yeah. So, but now with all of that washed away, guys got to start from scratch.
Exactly. And that costs money. It takes time. It's very intensive. So that's one of the things with these extreme events is it's not only the fact that the event happens and you maybe lose that crop.
Yeah, there's knock-on effects.
There's knock-on effects, right? And often like we just say it in passing, right? There was a flood. But it takes time to replenish that field. And it's tough, obviously, on the farmer. He's not budgeting for that. I mean, his parents never used to do it. Now he has to adapt to it. So it is what it is, sort of thing.
And I think when it's a big risk, a lot of insurances don't cover it.
Exactly, right? Or your insurance gets so high that you can't service it anymore. So that's the thing with extreme weather. Like you saw there, we said a bit of this, it depletes soil nutrients. There's an increase in soil erosion, which is not great either. Apparently, there's been, I don't know if I put this in here. I'll show it. Anyway, there's been a drought somewhere in the US for like 5 years. And it's a big like pastoral region. I thought that was wild. But anyway, so basically the risk of extreme weather almost always, so this is a different thing. So when we're looking at temperature, CO2, you can work with it. But extreme weather, there's almost always a decrease in crop yields because it's physically taking the crops away from you. Doesn't matter what you do. So that's the issue with that. And you see that nice graph I put there.
Yeah.
You like some visual things, right?
Even me, I like.
So you can see there in general over the past 100 years or so, we've been increasing crop yields per hectare. But when there's those extreme events, you get the dip. So that's the biggest issue with extreme events is it's hard to mitigate against them. You will see a decrease in yields, which is not great. Okay, but Mr. Hunselaar, all is not lost. There are ways around this, and this is going to be a part of the adaptability part that you spoke about.
Improvise, adapt, overcome.
Improvise, adapt, overcome, all right? So one of the things is going to be farmers need to plan better. That probably sounds terrible.
Well.
All the problems on you, farmers.
Yeah.
So planning is going to be, it's going to be a lot more like you need to talk to the association that you're a part of and make sure that you guys understand that all the farmers know what they're going to be planting that year, why they're going to be planting it, when they're going to be planting it, and how they're going to be planting it. So it's going to be a lot of planning around that. And I took this excerpt. I don't know if I should read it. It's probably not very good podcastiness, but you can see there.
You're good at reading.
I can read it, okay? So this came from a report from, I think it was the World Bank, and I'm just going to read it here. Warmer temperatures mean that in many countries, spring crops can be planted earlier. for the scenario of 3 degrees of warming, the researchers estimate that towards the end of the century, spring crops in many places should be planted 10 to 30 days earlier than they are today. On the other hand, winter wheat should be planted 10 to 30 days later so the crops don't develop too early or too quickly when it's vulnerable. Okay, so that, like I said, there's going to be a lot of planning with your association, unless you're a big conglomerate who can measure these types of things. Otherwise, you're basically setting yourself up for failure. And then you see my graphy there. You see this graph. It's a beautiful graph. Can I explain it to you?
Yeah, so educate me. All crops, maize, rice.
This basically shows
wheat.
a graph of if you're going to limit your exposure to not getting good crop yields, how do you do it? And the one way to do it is by shifting planting dates. So that's by checking what the weather's going to be, better planning, right? And maybe planting your spring crops earlier or later or whatever the story is, right? So that's the one thing. The other one is adapting crop varieties. So using different strains or using GMOs or whatever you guys all decide. And then that green bar is putting both of those together. So planting later or earlier and then using different varieties. So there is ways around this. There is ways for us to continuously increase crop yields, but it's going to take planning. That's basically the idea around that. And you can see there for all crops, we're looking at a 12% increase in yields. I think this was over the next 100 years, or there up to 2080.
Okay.
So there is ways to get around it, but it's going to take planning. Okay. The next thing I wanted to chat about is obviously using, is this the end? Oh goodness, I'm trying to throw things out here. The next thing I want to talk about is big data. Right? You use some big data, right? So farmers are going to have to actually start using big data. I think we're at the point of you can no longer be a small farmer and get away with it. This is not 1800 anymore. No one's getting away with not understanding the data. So farmers are going to have to start using big data sets in order to get trends so that they can plant and plan accordingly. Okay? And this is all going to take, I think, skilled people like engineers, like statisticians, like mathematicians, all of that stuff. Okay, so that's big data sets. The one thing that's a bit wild is that Africa is going to be disproportionately affected by climate change. I feel like we know that. Yeah. Like we always say that. It's like sort of it's how we live. It's sort of sad. But you can see this last graph that I put in here is basically the idea around this graph is that Africa's going to get left behind. So you can see that this is the potential. The potential.
I feel like you were thinking about potatoes.
Yeah, a little bit. So the potential for rain-fed cereal crops in sub-Saharan Africa to adapt to climate change. So you'll see all those bars there, which I'll throw up. But basically the idea is if you don't integrate newer technology like forced irrigation, you're going to be left behind. And because the climate's changing so quickly, you won't be able to adapt and your crops are going to absolutely fail. And then you're going to end up buying crops from countries that are using advanced technology and better planning. And that's Africa for you, man. Right? So plant production, food production, there's hope, but we're going to have to adapt. Like you said, there's no turning back, but we're here now. Okay? Any thoughts on food production? That was my last bit on
I must say, it's not as scary as I thought it was going to be.
There's ways around it.
It's
shouldn't have to make ways around it. Let's not get it wrong.
But here we are.
But here we are. We're here to address the problem. Then the final one, I just thought interesting, the built environment, obviously where we live, where we work, where we spend our time in the world. Will these buildings have to change? Immediate thoughts?
Yeah.
I'm
sure.
100%.
I feel like it's a no-brainer. Like, of course.
100%, right? And this comes back to a lot of it's going to be the extreme weather events we experience. So increased risk of flood, increased wind speeds, increased temperatures. The one that's very interesting is houses designed, let's say back in the day, for Joburg. Let's just do that as an example. Our houses and our roofs were never designed to accommodate the extra weight of snow. Okay. But if all the meteorologists get together and say, guys, over the next 50 years, if the climate keeps changing the way it is, we're going to experience snowfall in Joburg. All the houses that we stay in are at risk of the roof collapsing on you. So these are the things I think we have to think about, right? So I read a few things. There was a whole bunch of studies on this. And basically, it's about new houses getting built now. We need to think about the climate is going to get more severe. There are going to be these extreme weather events. How do we plan for them? And a lot of it's high wind speeds and snow. Obviously, snow is very heavy when it sits on your roof. So if you don't design for it, then you endanger not only the building, but the occupants inside. So it's going to be a lot more hectic. Again, I think the whole move around this climate change thing is you're not going to be able to just be a DIY oak who builds your house. Or you're not going to be able to be a DIY farmer. You can, maybe, but it's going to be more dangerous.
And difficult, maybe.
And difficult, right? To actually understand the maths behind it. No layman knows how to do a calculation to see if they can handle the weight of snow on their roof. Maybe you can watch a YouTube video.
Yeah, I mean, people...
There's ways, but I think as we go and as the events get more extreme...
I think the point you're trying to make is that you can't just rely on the way you've always done it. You need to sort of think about what are the new risks, you know.
Yeah,
we can't do things the way now that our fathers used to when they were our age.
Yeah.
Because things have changed.
We're moving away from a DIY world, I think, good or bad. It's the world we're moving into, and because the events are going to be so extreme, I think this is the thing. It's not the middle of the bell curve that's the ish, right? It's the tails.
Yeah.
So it's when you get events like snow or high wind speeds that a building that's not built with structural engineers who have looked at the structure itself, you're going to be in trouble. And I think the big thing comes back to you'll be fine until you're not fine, because it's literally people's lives at risk now. So thought I would just put that out there. It is actually very serious. So the last point I want to bring back here is a lot of the housing stock, specifically in South Africa, I couldn't find any data on it, but I know we have very old housing stock. If you look at the US, even the average age of housing stock in the US there is 42 to 51 years old. So that means houses now that people are buying were built back in the 70s, when we weren't thinking about how do we live in a house in 2050. Okay, so things are going to be different. And we're already in South Africa. I remember we did an episode on this on we are short of houses. Was it the sustainable housing thing, right? So we're already 2.4 million houses back. And now our housing stock is also old. And now we need to think about the future generation and what houses they're going to live in. So the houses that we currently have might not become safely livable, okay, in the future.
Like, I think we're lucky in the sense that our walls are strong. Like we use brick and mortar.
Exactly. But you don't know either. You don't know.
You don't know.
This is the thing. You don't know.
Don't know until you know.
You don't know until you know. So final point I'll end off with here. The UN estimates that about 230 million people live in what is defined or described as a slum household in sub-Saharan Africa. I didn't look up what slum household means.
I think they're talking about like shacks.
You can glean whatever a slum household is, but that's 230 million people that need houses that can handle extreme weather events. Okay, so big point here. Engineers are going to be a part of the future of not only homes, but the structures we live in, the places we go to work, all of these things, hotels, all of that stuff.
The roads we drive on.
The roads we drive on, the bridges we drive on.
They're kind of already a part of that.
We're a part of it, but we're going to be even more a part of it. Just a small anecdote. Most houses were not built to accommodate solar panels, for example. And I think in South Africa, it's not necessarily climate changes that's forcing us. It's the fact that electrical infrastructure is falling apart. So now you have to put solar panels on your roof that weren't designed for it. And this is why I think regulation is going to drive a lot of what happens in the world.
I think this is why you now have to get a license, because you have to get someone to inspect it and say, this roof can hold the weight of these solar panels.
Exactly.
And if you don't have that license, get a fine.
And I think it's good. It keeps people safe. But this is going to be the thing. We're trying to make houses that weren't built for the conditions they're in or going to experience. We're trying to make them work for that future. And it might not be the best. We might have to start from ground zero. So I'm going to finish off my section with one question, Mr. Hunselaar, that I think for Africa, the big question is going to be, how do we accommodate for new housing as well as renewing our current housing stock? Because remember, 230 million houses short, and we have to modernize the current houses that are here. I think we've got a big hill to climb in Africa. That's me. That's all the facts I got to give, man. What's your final thoughts? Climate change, are we going back? Are we going forward, sideways?
I think we're going sideways, to be honest.
Is it?
So, I mean, like we said, there's already irreversible damage, but hope is not lost.
Yeah.
Thanks to engineers and technology and scientists and some very clever people out there, we're getting workarounds.
Yeah, 100%.
And I think just moving forward, you just got to be aware of what's going to change and what you need to do to adapt to that thing.
Yeah, 100%.
You know,
yeah.
I think we're already at the point where it's too late to deny that it's happening.
No, it's definitely happening. I think we can see that. I think from my side, it's just engineers are going to play such an important role. And I think that's why the podcast is so important, right? It's about inspiring young engineers that you are needed, that your skills are important to the future of the world. That's you guys. You guys are important. And it's going to come to a point where there's not going to be a choice. At the moment, I feel like there's a little bit of, people could say, but there's going to be a point where there's no choice. We're going to have to adapt, like you say, adapt or die. And that's basically it. So that's me. Climate change. Can we go back? Can we not go back? I'm going to say it's an open question. I'm an optimist. But
Yeah, I think my whole thing is that like I think we're going to be able to work through it.
Yeah.
Like we're going to be able to figure it out.
we'll survive. Yeah.
But I don't think we'll be able to go back to
What it was.
what it was. Yeah.
Yeah, fair enough. Okay, Mr. Insulaw, recommendations? Give it to me straight.
Oh, so we've been watching The Peaky Blinders.
Oh, have you been watching Peaky Blinders?
Yeah,
okay.
have you seen it?
Dude, long ago, but I didn't watch all of it. Like
Yeah,
maybe
no, it's
half
rough,
a
dude.
season.
It's heavy watching. I'm not gonna
Is
lie.
it?
Yeah,
Takes
but
a
it's
bit.
it's a very good story. So you know what it's about. It's like it's just after World War II. Like a bunch of guys came back, and it follows the main character Thomas Shelby, and he's a businessman at heart, but he's also like the head of this gang in Birmingham, and it shows how he's basically building his empire.
Oh, nice.
So he starts off as like a low-level street gangster,
and
controlling the
basically
city he's in, and like how he basically, and he's crazy, and he's got balls on him, man.
Is it?
Like there's this one scene where like there's a gang war, and then this other guy comes up, and he's like, no, he wants to buy the scrap yard, but it's like one of his men, like Thomas's men, belongs to them. So he goes, yeah.
Wait, do the accent, man. Do the accent.
Yeah, he goes, yeah, no, I'm gonna butcher it. So he's basically like, all right, let's make it fun. Let's make it a wager. Let's flip a coin. Heads, you can buy the scrap yard, and you have my blessing to do so. But if it's tails, I'm gonna fuck your daughter.
Fuck me,
It's
dude.
hectic. No, like it's hectic stuff. Like
Yeah.
it's and then like the guy's like, and he's like, no, I'm serious about this. Like, if we flip the coin, we insist
Like it's a
that
deal.
the terms go through.
Yeah.
And like so that's like one of his rules. Like if he has a big decision to make, he'll flip a coin, and whatever
He'll abide by it.
he'll abide by it. So yeah, but it's good watching, man.
Okay.
It's
It's a vibe.
not for kids.
Yeah, got
not
you.
for kids.
And probably not a binging thing. Watch one or two. And
Yeah,
then you
watch
gotta-
one. You might binge it. Like it's each season has 6 episodes, like an hour long,
Okay.
and there's about 6 seasons.
Yeah. Why not?
But yeah, it's good watching.
Solid watching.
Yeah, yeah.
All right. For me, we've started watching Come Dine With Me again.
I like it.
Yeah, pretty fun. I like it. It's good jokes in there. Freaking weird people in the UK, dude. Flipping weird
I
people.
think there's weird people wherever you go.
No, I mean, fair, but like, weird people. But yeah, it's quite a jolt. Easy watching. I literally put it on in the background to hear some of the jokes. Really like it. So yeah, that's me, Mr. Hunselaar. Anything else from you?
Do you have any permissions to bitch?
I do not. Do you?
I do.
Okay, yeah.
Telemarketers.
Dude.
And I have sympathy.
But you
because-
have Poppy Act.
I have sympathy because I get it. These people are just trying to do their job.
Literally, yeah.
But like, so even like today, some insurance company phoned me and they were like, "Can we want to give you an offer?" So I was like, "Honestly, I'm not interested.
Don't care.
Don't
Yeah,
care."
yeah.
Oh, so but please do give us a chance. Give us a chance. So I was like, "No, I'm not interested." And then she just starts talking, so I just put the phone down.
Nice.
Was that nice of me? No.
No.
But like, please, when I say I don't want this,
I
take my
don't
word.
want it.
Take my word for it. Like, don't try and convince me.
But that's not a salesperson, man. Her job is to get you to convert.
And also, like Nedbank phone, like someone from Nedbank phones me the other day, and this is how the conversation went. It was like, we saw that you tick the don't advertise things, and we just wanted to call you and let you know about all the
What
deals
you're
you're
missing
missing.
out on.
I was like, there's a reason why I tick that box. It's because I don't want to have phone calls like this.
They were just trying to make sure you knew what you were doing, man. Sorry, dude. I'm sorry. I hate telemarketers as much as anyone.
Yeah.
100%. I don't even listen anymore. I just say, take my name off this list. And then I put the phone down. Do they take my name off the list? Probably
No.
not.
Couldn't,
No?
They probably couldn't be asked fucked.
Thank goodness for the Poppy Act. All right, guys. If you want to get in touch with us, it's highlevelpodcast@gmail.com. We will keep your email and we will email you marketing things. Maybe we even call you. Leave your number. We will call you and try and sell you some type of insurance or
Or maybe we'll just have a good chat, you know?
just to have a good chat, right? We'll just phone you and have a good chat. Follow us on LinkedIn. It's Jonathan Dalport, Damon Hunselaar. All the links to all the resources that we use to research and everything will be in the show notes below. Thank you guys so much for staying with us to the end of this episode. We love you guys. Thank you for making this possible. We will catch you in the next one.